So, now we are going to find surface areas. We have found length, we have found areas under curve, we have found volumes of solids of revolution, but we are now going to find surface areas of solids of revolution. So, if you look at a cylinder and I am supposed to find the surface area. So, what is a cylinder? Cylinder, if you take the cylinder, cylinder is like this, but you cut it along vertically along a line and you open it, it will be just be a rectangular paper. If you take a paper cylinder and I will just get a piece of paper which I see here. So, here I am trying to make a cylinder. So, here is a cylinder of some radius, right. Here is a cylinder of some radius. Now, what is the length of this circumference at the base? It is 2 pi into the radius of this circle, and that is exactly the length of this line which we have used to make this cylinder. So, that is it. So, basically if I cut along this line, I get back a rectangle, the cylinder becomes a rectangle. So, that is a key idea when you are working with surface areas, is that suppose you have this situation that is x, this is y, and basically I have rotated a rectangle around this x axis. So, what I generate is a cylinder. So, this is of radius r, which is the length of one side of the rectangle or half of it. So, then if you take any cross sectional area, a cross section of this, basically you are chopping it off, then what is the length of this? Basically this is for the rectangle, this is same as 2 pi r. So, basically, so what is the surface area? You basically move this small area over this whole domain. Basically you chop up the whole thing into small pieces, and each surface area, if you take all the surface area of the small pieces, small chopped pieces, and sum them up, they give you the surface area of the whole thing. So, that is the key idea basically you have. So, if you, so this is your y basically, y or r or whatever, this is your y and this is your say change in x. So, you know how to, so it is basically 2 pi y, that is exactly into this. So, how do you, so 2 pi I y is the surface area when I make the change of del x, right. So, 2 pi I into del x when I make a unit change just for 1. So, 2 pi y is my surface area. So, those 2 pi y surface areas, if I can sum them up over this whole length, that is integrate them. So, basically it looks like it should be something like this, something like 2 pi I f x, integrate them from x varying from say a to b, that should possibly give me the surface area, because 2 pi r is the circular surface area that I am envisaging in the body. I am not going to get into the details of how a surface area is done, but a surface area could be like this. For example, So, in this case how do we come to this sort of formula? See what happens. So, this is, so if I move over delta x zones, they essentially you are thinking that delta x has slices each having surface area 2 pi x. So, when I am moving over a length delta x, my total surface area is 2 pi into delta x, that is the intuition. And hence if you sum them and take the limit as delta f y is nothing but a fixed y in this case, some or f x if you want, if you just call f x or y or r 2 pi r delta x. Now, if you sum them up for the cylinder and take the limit as n tends to infinity as delta x goes to 0, this is nothing but the integral, says a to b. So, that is the, and this becomes dx. So, it is 2 pi r b minus a. For the cylinder, but it is not that that is the only thing, but this is the cylinder is the only one whose surface area we are trying to find. Surface area could be like this also, where you know this thing is not straight and you know these do not have equal surface areas and the surface areas changes, where this fx would start playing a role, right. And in this case, suppose you have a scenario like this, I will generate the ideas intuitively for you. So, 2 points A and B, I take the 2 points A and B. So, this is a solid of revolution, right. X axis is actually going through the middle, my drawing might not be fine. So, I have chosen one, so this radius might be y1, this circular radius must be y1 and this circular radius is y2, drawing is very bad, I accept it, this is y2. Now, you see this areas of this length of this circumference is changing over this length. So, this is a part of this whole object, say the whole object may be very big. So, this length is del s and what I do, I look at into something of an average, right. I look into what could be, so this is varying, right, this is this to this is varying, the shape of the circle, so the circumference is varying. But here again comes the idea of tagging, so you tag a point. So, the idea here is that here is the curve is changing, there is a del s, the change in the arc length. So, here del s is small, so here when I make the change from this to this little big, there must be something which is in between, average, which most of the lengths are near to that length. So, we find some y star which is the average of these two and take that y star and that area as a representative one. And we say that the area of this frustum, so the surface area of this frustum, surface area of this part is more or less same as 2 pi y star into del s. So, I assume that all of them are almost of this area of the length of these are on the average that is this. So, it is on the average the total surface area is this, is approximation, it is a good approximation by the way. You cannot say this is exactly exactly the surface area, but okay. Now, how to handle this situation? From here what can you say? How to make an intuitive jump? The intuitive jump would be that essentially what you do is you integrate 2 pi. So, you just cannot take one average point, you take f x as the function value changes, which is y, into d of s. But what is d of s? It is root over ds, this as s becomes smaller and smaller, it becomes ds, is represented as ds. This is nothing but dy by dx whole square dx, and where x is moving from wherever, x1 to x2 or a to b, whatever you want to say. So, this is the surface area. So, just by using your intuition, how much can be achieved. So, here we have obtained the formula for a surface area by just by intuition. So, I am not getting into the nitty gritties every details of proofs. Of course, the time is less. If we just do the proofs, then we do not know examples. But again, the idea is you have to see how does the idea comes from. There is a lot of approximation built into it, which and the approximation vanishes when we take the limit. That is the idea. Approximations hold in when we are looking at a very small piece of the whole structure, but then in the limit the approximations vanish and they give an exact answer, right. Now, in an example that I want you to find. Now, this is what you have for a curve y equal to fx. Now, suppose I have a curve which is parametrized. So, if the curve is parametrized like a circle, and the t is the parameter, then what would be the formula? The formula is simply this, that the total surface area S A is integral a to b 2 pi f of x into their length is given by what? In the elemental length is dx dt square plus dy dt square, y of x is y, that is all. As simple, sorry, this is not s, is dt. But what is fx? You do not write fx, fx is y. So, y is some g of t basically. So, this is how you write the case when the curve is parametrized. Here where the curve is non-parametrized. Let us take a simple example and see. So, you take the curve fx equal to x square between x lying between 0 and 2. So, fx equal to x square x lying between 0 and 2. So, here is an exercise problem in the Thomas's calculus. So, when I am writing, so I am trying to find when x is between 0 and 2. Basically now what I am doing, I am rotating about the x axis. So, if I rotate about the x axis, the surface area finally, so this is x, this is y, the surface area would look like some funnel. Something like this. So, again what is the area for? So, I am taking the function fx equal to x square, x is between 2 and 0 and I am trying to find the area. Fx equal to x square and x is between 0 and 2 and I am trying to find this area. It looked like a strange funnel type of thing or a trumpet type of thing. So, in that case what will be my surface area? SA would be 0 to 2, 2 pi x square is fx root over 1 plus what is dy dx? Dy dx is 2x whole square into dx. So, you immediately see it is 0 to 2, 2 pi is out, x square into root over 1 plus 4 x square dx. Now, you need to integrate this. I do not see a very simple way how you can integrate this, at least it is not coming to me. It's so here the integral might be complex or may not be. So, maybe I will first try to do a little bit of by parts and see what happens. Still it would be very complex because here I have a root, and if I do not integrate this, then I am in a very bad situation. If I integrate this out, this is all right, then some cube will come and then okay. So, if I try to integrate this root over 1 plus 4x square dx, I do not know a function whose derivative is this. So, you cannot do it in terms elementary terms. So, you see a very simple looking function, it gives rise to a surface area which cannot be computed directly in elementary terms. So, what are you going to do in such a situation? So, such a situation you have to talk about numerical integration. So, here I am bringing you to the reason why we need to talk about numerical integration. So, you numerically solve this problem. You partition the x axis, y axis, do something, there are several rules, Simpson's rule, trapezoidal rule, we will come to all these, do not worry, but this is what it is. It looks to me, if I am there, I would like to go for a numeric integration. I think just symbolic integration, just using antiderivatives is not possible. I do not know a function whose derivative would look like x square into root over 1 minus 4x square. It looks quite fearful to me. Okay, let me try with another exercise. We will end with the circle today. We will end with the circle today. The surface area of a sphere today, but let us so okay. Let me still try this problem out a bit, and then try out some problem. Maybe I would go for numerics immediately, but I think I have lost the patience. But okay, let me just go ahead. 0 to 2 x square root over 1 plus 4 x square dx. So, if I try this out, I do not know because I keep x square, I do not integrate, I take this as a first function and try to integrate root over 1 plus x square. What would be the integral? I do not think there is any way, because the problem here is this: if here this was a higher power than this, it was x cube, then I could possibly use something, because I could make the derivative of x cube equal to this. So, but here the powers are same, so I do not know what really to do with this but to numerically integrate. So, I do not know a scenario which is good for this. So, some other little looking stuff, for example, tan x between x lying between 0 to pi by 4. This is an exercise problem. So, I am again just trying. So, if you have tan x how does tan x look like? Tan 0 is 0. Goes like this, is pi by 2, and tan pi by 2, tan pi by 4 is 1. So, if you rotate this around the x axis, we will have some strange looking stuff. So, if you rotate this, so this is your object, this sort of some strange looking stuff, strange looking, it is like a bowl. So, here what I will do is a tan x business. So, it is again the surface area is 2 pi 0 to pi by 4 tan x into root over 1 plus dy dx, the derivative of tan x. So, it is cot x. So, dy dx, I forgot derivative of tan x. What a strange guy I have become that I have forgotten the derivative of tan x. So, maybe just tan x's derivative is cot x sec square x. So, root over 1 plus sec square x. Sec square x whole square. ddx of tan x is sec square x whole square dx. So, you see here you again have these sort of strange formulas, and so sec to the power 4. Now, if you look at the derivative of sec square sec to the power 4x, then it is 4 sec x into sec x tan x. So, here immediately you do not have the derivative. So, again it's all a numerical setup that you really have to go into. So, take a very simple situation. Let me see where you can do something like y equal to x. This is the line y equal to x. So, if you rotate it, you form a conical structure and you are asking its surface area. So, it is 2 pi is 0 to 1, 2 pi f x is x root over 1 plus f x square is 1 dx 0 to 1. So, this is handleable. So, it is 2 pi into root 2 0 to 1 dx. So, it is 2 root 2 pi is the answer, is the surface area of the cone of the conical structure. So, you see several examples where you can solve, several examples where you cannot solve, where things are very bad. So, we end our discussion today. So, here something is missing, numerical integration. So, we have to now get into our hands in what is called numerical integration. We should be able to do some numerics somewhere. So, I will try to use a mathematical software called Maple to show you how you can do symbolic integration or you can do numeric integration. When I start numerical integration, which would be the end of our real integration part, and going to more advanced stuff. So, let me now talk about the spherical, the sphere, right. So, what is a sphere? How is it obtained? So, you take it on the x axis, you take the circle and rotate it, you get the sphere. So, you take a circle and rotate it around the x axis, you get the sphere. This is exactly what you get when you have this is exactly what you get when you have this is exactly what will happen when you want to get a sphere. You rotate that circle, you get the sphere. That is exactly what we discussed yesterday. That is what I was supposed to tell you. Now, here we will use the parametric business again. So, we will use the simple situation where x square plus y square equal to 1, because I do not want to get into this R business, this is just an additional thing. So, x square plus y square equal to 1, this has been, so let me write x equal to cos t, y equal to sin t. So, I will go by that formula, S of A is equal to 0 to now 2 pi, because t varies from 0 to 2 pi, that you already know, and then I have 2 pi into y, y is sin t, and the length as you know, we have already done it in the last thing, which is sine square t plus cos square t. We have done it in the last class when we are talking about length. So, what you have? It is 2 pi 0 to 2 pi sine t dt. So, it is 2 pi minus cos t 0 to 2 pi. So, cos of I am finding the surface area. So, now you see if you do this you get surface area to be 0 because this will become cos, this is 0 minus minus plus 0 0 1. So, it will become minus 1 cos 2 pi is cos 0 which is same as 1. So, minus 1 minus minus 1 plus 1 it will become 0. But that is very strange. The idea is this, the idea, then how do I get the surface area? The idea is that if you are doing that, idea is not to look into this because surface area has to be positive. Surface area cannot be 0 or anything, we are really finding an area. You have to observe that this curve sin x, when you are integrating from 0 to 2 pi, it is like this. So, one area is positive, one area is negative, and both the areas are actually equal. One is negative area, one is positive. As I said, you going counterclockwise, and then immediately you will know that they cancel each other. So, we do not want this. So, what we want is a modulus of sin t basically. So, essentially what we want is we just have calculate one of these areas where sin t is positive, and then you will take the double of these things. That is what we want. So, basically we want modulus of sin t. So, modulus of sin t would give you like this. So, these two areas is what we want. So, otherwise the surface area would have no meaning. So, this is 0 to pi by 2 because you have to understand that where here sin t is only so 0 to 2 pi, sorry 2 0 to pi, to 2 0 to pi, right. This is something important. So, instead of having 0 to 2 pi, you have 2 0 to pi. So, if you do this, so let us look at the just 0 to pi, what is the integral. So, basically I am taking the absolute values, right. This is something very important that we should observe, that y when you take it has to be positive, this y has got to be positive. So, without positiveness you cannot get the things. See this, so what we now learned that if I do not have my y value positive throughout my domain of integration, then I will get 0 answer in these sort of situations where you have symmetry. So, that is not a good idea. So, in this formula thus is valid if y is greater than equal to 0 for x belonging to, for t belonging to b to a. So, this is something very very important that you have to understand, that I have to only choose those y's, that y should be non-negative when t is belonging from b to a. So, you see getting stuck in this problem that you just directly integrate, you get 0. So, you know, oh, come on man, how can a surface area be 0? You understand that there must be something which we have missed here. So, now this is how mathematics is built. So, here I am getting something which is not matching with reality. So, there must be something which I need to put here assumption, so that the whole thing finally matches with the real stuff. So, here y must be greater than or equal to 0. You see here I just want to look at sin t then between 0 to pi and then from 0 to pi. So, basically 0 to 2 pi mod of sin t. So, both the positive parts. So, this is, so only if I write it in this way, only if I take 2 into the positive part, because these two areas are same, I basically get the area under this curve. Basically I should write not sin t, I should write mod sin t. So, basically how do I then find the surface area? So, I just find the surface area of a little part. where my angle varies from 0 to pi by 2. So, between 0 to pi by 2 my stuff is positive, and then I just multiply it by 4. So, this so you see what I now see, that this sin t is positive because we have written y x equal to sin over y cos t y equal to sin t. Sin t is positive when x is between 0 and pi by 2 or even 0 and pi, right. So, sin t remains positive, then it goes to negative. So, if you have just do 0 to pi by 2 sin t d into root over, of course, you know 2 pi is outside, sin square t plus cos. See, one single problem, just the circle, sphere is teaching you so many things. So, these are mathematics is done by guess and test. You try to do something, something fails, you see that okay, it does not match with reality, you go and do the corrections there and then try to figure it out how you will do it. So, 2 pi, so this is how stuff are done in math by guess and test. So now what I do? Now I do the same integration. Now I have 0 to pi by 2 sin t dt. Let me see what does it give me. It gives me 2 pi minus cos t 0 to pi by 2. So, cos of pi by 2 is 0 and cos of 0 is 1. So, is equal to 2 pi. So, that is my answer. So, you have got 2 pi. So, basically 2 pi is the surface area of what? When sin is positive, that is, if you also wanted to put pi here, then it would have become minus 1, 2. So, essentially you have to just bother about this part when. So, now what I have to do? I have to just multiply it by 2 to get the full answer. So, I have got the half of the thing. So, here, so what I have done? So, 2 pi is not the answer, answer should be 4 pi r square, that is what I know. So, sin t you know is positive between 0 to pi. So, integrate from 0 to pi, do not integrate from 0 to 2 pi. So, here you will be only restricted to the case where y is greater than equal to 0. So, if y is greater than equal to 0 between the interval a to b, you integrate between that. So, y is greater than 0 between 0 to 2 pi, 0 to pi, and that will give you the surface area. Do not take the whole range here, right, from 0 to 2 pi. So, if we do, this is simply means cos pi is minus 1, minus 1, minus 1, plus 1, minus 1, minus 1, plus 1, minus 1. So, if you have this sin from 0 to pi, so let us do it. What happens? The surface area is 2 pi into minus cos of t 0 to pi. So, this is 2 pi into cos of t is cos of pi is minus 1, minus 1, minus 1. So, it is again giving me 0, minus 1, minus 1, plus 1. This is minus 1 cos, also minus cos of t. So, it is minus 1. So, it is minus cos of t is minus 1. So, it is giving me 2 pi into minus 1, minus 1, plus 1, minus 1, minus 1, plus 1. So, it is 4 pi. So, you see, by choosing the range where sin t is non-negative, I am getting the area. Sorry, I made a mistake, pi by 2, that is not correct, it is pi. So, I have to choose the range where sin t is. So, if I had chosen pi by 2, you have to multiply by 2 because I have just broken the whole thing into 2 parts. So, the surface area, when you do this when you use the parameterized curve, you only have to consider this is only possible, this integration is possible if y is greater than equal to 0 in your range of integration. So, what you have to do? You have to get the whole thing done where this is positive. You have to actually take the range of integration where sin t is positive, only in that case you will get the surface area, otherwise you will not get it. If it is not positive, because that is what we are doing, because if you look at this, what is this? This is the positive part of the x axis, not the negative part, and then we are multiplying with the positive part. So, basically I have to look into the case where sin t is positive. So, basically surface area or sphere, you are taking it like this. Here this y is your sin t, but sin t here, the y is positive here. So, that is possible when you are varying between 0 and pi, that is when your angles are varying between 0 and pi. You are only looking at those y's, and then you are calculating the areas, because if you take the y in the negative side, you have to take the negative value, because we are in the coordinate system. But you do not want a radius to be negative, you want to take only its length, which is just the positive part. So, it is enough to integrate, so enough to look at the whole thing where the whole thing is positive, because you are just taking this, the circumference of this, and you are just moving this circular disc throughout. Obviously, the y keeps on changing as the t changes, but you are moving it, and that summing up of those lengths, each of those lengths, if you small lengths, if you gather them up, they form an area, and that is exactly the idea. That is why y needs to be positive. This is something which is very, very important and has to be kept in mind. With this, we end our discussion of the second lecture of the 7th week. We have to do something more about numerical integration. That is what will be done on the third one. The last 7 lectures would be on sequence series, Taylor's theorem, and all this stuff. And the very last lecture, I hope, if I have time, we would prove the irrationality of pi, which will show you the application of integration, application of Taylor's theorem, everything, to prove one concept, that the number pi is not rational. So, we have told you how the number pi has been generated, showing that c by d, the circumference by the diameter, is constant. Thank you.